Hello everybody, welcome to Homework Helper for 4.6. This is the last Homework Helper of the fall term. That's gotta feel pretty good. Let's go ahead and look at this ready section. I'll go ahead and do the first problem with you guys so that we can kind of model that for the next couple. We're going to be solving equations and equalities from a context. So pretty much what we're going to be doing is we're going to be taking story elements and turning those into math problems. So nothing too unusual, but let's go ahead and look at what's going on. A local amusement park sells summer memberships for $50 each. That seems like it'll be important. Normal admission to the park costs $25, and admission for members is only $15. So it appears we have to buy a membership for $50 to get that $10 discount. So if Darren wants to spend no more than $100, so $100, no more than 101 would not count. So we were looking at a sum number that is less than or equal to 100. Okay, that's no more than. On trips to the amusement park this summer, how many visits can he make if he buys a membership with part of that money? Okay, so with part of that money, he's going to buy a $50 membership, and he's going to add to that $15 per trip. So that pretty much sets up our equation. We have 15 per trip plus the $50 membership, and that's all got to be less than or equal to $100. So now we just need to figure out how many trips he can take, how many visits. So if I subtract 50, I get $15 per trip. It's got to count for $50. So if I divide by 15, divide by 15, I get a number of trips equal to, well, I don't know 50 divided by 15 off the top of my head, so let's go ahead and use a calculator, and we see that we get 3.3 bar. And so since you cannot, so since a trip to an amusement park is going to be a discrete relationship, you can't go to an amusement park 0.3 times. That doesn't make any sense. You either go or you didn't. Since that's going to be the relationship, we kind of have to drop everything after that decimal and just pretend it's not there, and we can say that he can go, Darren, yes. Darren can go a maximum of 3 times. Okay, so how many times can he make? He can go 3 timerinos, 3 times. Okay, that's A. Boop, boop, boop. B. How many visits can he make if he pays normal admissions instead? Okay, well, he still has the $100 that he can't spend more than $100. It's got some numbers less than or equal to $100. But this time, he's going 25 times, or $25 per trip. There's no plus 50. There's no fee. So he starts there. And so from here, we just divide by 25. Divide by 25. So t is less than or equal to 4. So he can actually he can make 4 trips if he does it this way. Okay? And so for C and D, it asks us to do the same thing. If he increases his budget to 160, how many visits can he make as a member? Okay? So now he's got 160 is the number he cannot go above. So we still have the 50. We're still adding $15 per trip. So we subtract the 50, 15 per trip is less than or equal to 110. And so from here, let's just scoot this up a little bit. From here, we just divide by 15, calculator, 110 divided by 15 is 7 times. 7.33, but then again, just as before, we have to drop the 0.33 because you can't go to the park 3.33 times, 7 times. And so as a non-member with a budget of 160. So very similar, 160 is less than or equal to, but this time we're using the $25 number. Whoops, can't quite see it. The $25 number. Yoink. So $25 per trip, divide by 25, t will equal, what, 6 point something? So now you can do it 6 times. So we see that 160 is kind of that threshold where buying the membership matters. He has to go 7 or more times for that to be the threshold. Okay. So that's pretty much what we're going to be doing for number 2 as well. You kind of look at our context, find the significant numbers, build your equation, and go from there. Let's go ahead and turn the page. So here, we're going to be solving inequalities and justifying each step. So we're going to divide by -5. We're going to divide by -5. And the reason we're able to do this is the division property of equations. But then that becomes x is greater than 7. Why did the sign switch? Because of the negative division property of inequalities. That's it. Same thing here. I can subtract 68. I can subtract 68. That's the subtraction property of equations. And you can see I just started to like simplify it. We know what this means now. So we got x is greater than or equal to 7. Okay? That's pretty much all that's asking you. The further ones will have multi-step equations, 2-step, 3 steps, so that you're going to have to do a little bit more. So I recommend, now that we know what these stand for, the subtraction property of equations will be useful. If you ever multiply, let's put this down here, or divide by a negative, we're going to call that the negative division or multiplication property of inequalities. And you pick the D or the M based on if you're dividing or multiplying. Sweet. Go to the last section. We are going to be solving inequalities. So I'll do number 9 here. Number 9 asks us to solve for x, and so I'm going to add 8 to both sides so that x is greater than a -12. I find -12 on my number line. It's right here. I determine if it's an open or closed circle by the sign. I see that it's a greater than sign. That means it's open. If it were or equal to, that would be closed. And I also see that x is greater than 12, so that means all these numbers going this way are the ones that count in my solution because they're all bigger, they're all larger, they're all greater than this number. So let's go ahead and look at number 11. Solve each multi-step. So we're doing the same thing, except it's going to be multiple steps. I'm going to subtract by 3, subtract by 3. 4x is less than a -4. Divide by 4, divide by 4. X is less than a -1. Well done. That's all there is to it. And then finally, I'll go down to these ones where it's asking us to solve literal equations. And remember, literal equations means that we're trying to solve for a letter, quote, letter, which also means a single variable. And so pretty much with this variable, thinking faster than I can write. So pretty much what that means is that we're trying to get this in terms of a certain variable. So what we have here is when we have, I'm going to rewrite it on this. So we got f equals 9/5 of c plus 32. And this is the Fahrenheit to Celsius conversion. And so what we're trying to do is we're going from Fahrenheit to Celsius. We want to be able to go from Celsius to Fahrenheit. So what we're going to do is we're going to subtract 32. Subtract 32. I get f minus 32 equals 9/5 of a c. I now want to get rid of this 9/5 on the c. So whenever I'm multiplying by a fraction, to undo it, I multiply by the reciprocal. So I'm going to multiply by 5/9. 5/9. And so that 9 and 9 cancel, 5 and 5 cancel, leaving me with 5/9 f minus 32 equals c. And that will be good enough for our answer. Thanks a lot for watching, and be prepared for the test.